All right, so this is day 2 of 6.4. Sorry I'm out today, but it just had to be done. So we can still make progress. You will have a quiz at the end of the period today on some previous stuff, but let's keep moving with log properties. So remember, 6.4, the section of the book, had a whole pile of properties. And so we've broken it up into 2 days. Last class, we talked about the power property as well as the product and quotient properties from your formula sheet. Today we're going to have a couple more properties, and then we're going to focus a little bit on this second question here. We're going to try to solve equations. So we've been practicing all these properties. So think about in pre-algebra when you practice the distributive property, and then all of a sudden that distributive property was one step in solving equations. It's going to be kind of similar here. We've been practicing all these properties, and then the last few examples, we're going to actually try to put some of those properties together and solve for the missing variable x. All right, so see how this goes. So we're going to start off with a warm-up. Here it looks like there are 6 problems. These are based on the last homework, the first half of 6.4. So why don't you try these 6 problems, give you about 10 minutes or so, and pause this, and then let's get started, and I'll show you my methods. So good luck, and let's work on these first 6 problems. Okay, so let's go ahead and work on these. Simplify. So for number 1, I'm trying to break this down into the simplest, smallest form that I possibly can. 6, that's no problem. That's the number 6. This, remember what a log is asking. This is saying 2 to what power would give me a 4? So that means this whole thing equals 2. 2 to the second power equals 4. So now my problem really is 6 minus 2, and that is 4. Okay, something similar over here. 3 to what power is 81? 3 to the 4th power is 81. So that means this here is 4 minus, and then this, right? 4 to what power equals 1/16? Well, 16 is 4 squared. So that means this would have to be a negative 2 for it to be 1 over 4 to the positive 2. So this whole thing here equals negative 2. Right? 'Cause remember the question. 4 to the negative 2 power equals 1/16. So this logarithm is equal to negative 2. So 4 minus a negative 2 is a positive 6. All right. First 2, those are tricky on purpose, but hopefully they make sense now that you've seen them. All right, so our goal is to write them as a single logarithm. So notice I have 2 separate logarithms here. This is where we're going to focus on our properties from last class. So first, let's have the frog jump over the log. This is my power property. So this becomes log base 7 of y squared plus log base 7. And then be careful, right? This whole group, xy, this whole thing is to the 5th power, not just the y. So I'll show you in 2 steps. So there's my power property. And now let's go ahead and distribute this sort of power using my powers of exponents. Let's bring that in and make that x to the 5th, y to the 5th. Sorry, it's shaking the mount of the camera every time I write. And now we have the product property. The sum of 2 logs can be written as the product of a single log. So this will be x to the 5th, base 7, x to the 5th. And then these can now be multiplied together. So we add the exponents when we multiply the bases. There we go. All right, let's try the next one. So now this coefficient applies to this whole thing. So I'm going to go ahead and simplify this first. I still have 2 here. Log base c of a to the f over, so subtraction means we divide. That's our quotient property. So this is 2 log base c of a. And then this becomes my power with my power property. So my answer is log base c of a squared. All right, next one. Number 5. So the issue, right, if I'm going to combine these into a single logarithm, I need to write this 3 as log base 2 of something, right? I need logs with the same base if I'm going to apply these properties. So I'm going to rewrite this 3. So the log base 2 that is equal to 3. So 2 to what power? Sorry, 2 to the third power equals what? So 2 times 2 times 2 is 8. So this is a way to write the number 3, but with a log base 2. 2 to the third power is 8. So we've got that. And now that we have logs with the same base that we're adding together, we can use our product property. Log base 2 of 8 times x times y. Okay. Let's do one more. Last one. I see a subtraction here, so this is going to be my quotient property where I divide. But first, I need to send this frog over the log here. Power property. Four squared is 16, and x squared is x squared. We've got that. Let's pause that for just a second. All right. Sorry, I was answering some forecasting questions. All right, so on this one, what the heck was I doing? Oh, okay, so first I had the frog jump the log, power rule. 4 squared is 16, x squared. So I rewrote it here, and now it's subtraction. So that means we can write this as a quotient. And so now we have the log base 6 of this. And this is a fraction that I can simplify. 8/16 is 1/2. X over x squared is just an x in the denominator. So I can simplify this a bit. I think that's what it looks like. All right. So there's your warm-up. I hope it went well. All right, so that's if you're having trouble with that stuff. And we get more practice on it today, but it's also go back to your last homework assignment, that's 6.4 day 1, and try a few more of those problems. All right, so let's go ahead and move down to some new material. So we've got a couple more properties today. This is a really powerful one, exponential logarithmic inverse property. And so what it's saying here is that if you're taking the log of some exponent and they have the same base, then these two sort of cancel each other out. Now think about what inverses do. If you add and subtract by the same number, or if you multiply and divide by the same number, right? Those are inverse operations, and they sort of undo the work that the other one did. So in this case, when I have a log of an exponent and they have the same base, or if I have an exponent with a log up in the exponent and the bases match, these inverses sort of undo each other. And what's left, and what I mean by undo is sort of cancel, like using inverse operations. And what's left is this x value. So this is kind of cool, and there's a few different ways I can show it. But let's just think about our power property here, right? If this power, this frog jumped over the log and came down here, it would look like this, right? And the log base b of b, so this part right here is always going to be 1, right? Because the question is b to what power equals b. So the answer is always 1 when you have the base and the thing you're taking the log of, they're exactly the same. So yeah, of course that's true. Of course x times 1 equals x, right? That's what that looks like from the power property, frog jumps over the log perspective. But there's another way to kind of show it. Let's start with just let's start with our basic. If y equals b to the x, then we also know that log base b of y equals x, right? So this is just like our basic definition of a logarithm as the inverse of or just how do we rewrite? This is our changing forms, right? So this is the two of the same thing, right? I just wrote one in exponent form and one in log form. Well, watch what happens now when I take this and substitute it in for x right here. Y equals b to the log base b of y. So notice, right? B raised to the power of log base B. These cancel, and I get y. So that's just exactly what we have here, just the letter x instead of y, right? Same thing happens if I take this y. What if I took the same relationship here, but this time I took y equals this, and I took this, b to the x power, and I put it in here for y. Then I'd have log base b of b to the x equals x. Oh, that's exactly what we have for our first property, right? So simple substitution using just our exponent and log of the same relationship. So I think that's kind of neat. If you don't really care about that, you just have to memorize it. It's a little tougher to remember it, but you do have your formula sheet as a reference. All right, so what we're doing here is, notice, we have the bases that match. Taking the log of an exponent, the bases match. So this is 4. Right? The other way you could think of it is, you could have the frog jump over the log. There's another way to think of it. We have the frog jump over the log, right? 6 to what power is 6? So this whole thing equals 1. So we have 4 times 1 is 4, right? So either way. In this case, this is log base 7 of 7 to the third. So these are going to cancel. So I have 2 times this bit right here becomes 3 minus 6 to what power is 36? 2. So this is now 6 minus 2. So the answer is 4 again. Here, here's our other property where we have an exponent with a log up in the exponent, and they have the same base, right? The bases have to match. So this becomes the number 5. And then 2 to what power is 32? Let's see here. 2 to the first, 2 to the second, 2 to the third, 2 to the fourth, 2 to the fifth. Okay, so 30, this will be to the fifth. So 5 minus 5. 2 to the fifth equals 32. So my answer here is 0. Okay. A few more straightforward type problems. All right, why don't you try these? Some of these are a little bit tougher, but still doable, and you may make some mistakes, but that's, remember, encouraged. So why don't you try these 3 problems as you try it, and maybe just spend about 5 minutes on it, and then push play, and let's see what the answers were. All right, so hopefully you had a chance to try these. So I'm looking, this is like, here's some number minus another number. Here's some number minus another number. Here's some number minus, why didn't I add any? That's weird. All right, so let's see if I can do this like one piece at a time. So the left side here of D, the you try it, let's see how you did. I've got my 7s that cancel, both bases match. So this bit, a little bit of the expression equals 11. And then this one is asking, so let's do subtraction. 3 to what power equals 27? So this whole thing here becomes 3. 3 to the third power equals 27. So this is now 8. Once again, I've got bases that match. So this first term here becomes the number 9. And this one's tricky. So we have minus 10 to what power equals 1 1,000th? Well, remember, 1 1,000th equals 1 over 10 cubed. So 10 to what power would be 1 over 10 cubed. Here we have to be comfortable with our negative exponents, right? And so this is the same as 10 to the negative third. So this is negative 3. This bit right here is equal to negative 3. 10 to the negative 3 power equals 1 over 1,000. So now I have this 9 minus negative 3. That's like adding, so 12. All right, last one. So far, if you made it through that one, I think you're doing really well. If this little bit gave you a hard time, that seems pretty normal, but hopefully you got at least this left side as number 9. All right, so on this last one, F, I've got bases that match. Let's get rid of that. Call it the number 5. And then 2 to what power is 30? Didn't I already do this? I must have messed this up. Oh, here it is. Oh, I did. I totally messed this up. All right, so maybe on your problems, I will change this, but obviously I did not change the problem when I copied and pasted it above. All right, so this is the same exact problem. If you miss this, shame on you. Pay attention. Come on, it's the same problem. It's okay. Just focus. All right. Let's go ahead and take a look at the back, and feel free to ask your neighbors questions or get anything that you might have missed here. So let's take a look at the back. Okay, this is the last one of the day, and so notice, as you look at this page, notice now we've got a whole bunch of different types of equations, so we're actually solving for x here. So this is going to be the last property in 6.4, the one-to-one property of logarithms. We saw the one-to-one property of exponents, I think a couple classes ago, and basically that one said, if you have some base to a power that equals the same base to something else, well, then x and y have to be the same. That just kind of was intuitive. Oops. Right? If these things are supposed to be equal and the bases are exactly the same, then these things must be equal, right? So we have the same exact idea here for logarithms. The key here is only one log on each side of the equal sign. This property is the one-to-one property. It's called the one-to-one property. And so students get excited. They're like, oh, we've got one-to-one. Oh, logs, we can just cancel them. Wow, that makes my life a lot easier. And so they look at problems like B, and they just start canceling all the logs. However, this is not a one-to-one in example B. This is 1 log equals 2 logs. So there is no 1-to-2 property. This is the 1 log to 1 log property. All right. So let's go to and see how this works. In this case, right, in A, I have bases that are the same. So that's a good sign because that has to be true. And I've got 1 log on each side, so that's great. The only issue here is I need to do the frog jumping over the log. Make that a square up there. So now I've got log base 4 of 2x equals 2 log base 4. Oops, sorry, no 2. Scratch that out. 36. We went ahead and squared that. So now that I have 1 log equals 1 log and the bases match, I can ignore that and solve. Divide both sides by 2. So x is 18. Probably. No guarantees here. So I'm going to go ahead and check my work by plugging it back into the original. Okay, this looks like it'll be log base 4 of 16 with a log jumping over the frog jumping over the log. That's also 36. Sorry, 36. 2 times 18 is 36. And then 6 squared is 36. So these appear to be equal. So I think we're in good shape here. So the answer is 18. Okay, let's try another one. Okay, so I'm going to do, it's the one-to-one property. So I'm going to go out on the left side and have my frog jump over the log. Then over here, I have 2 logarithms, but they do have the same base. So I'm going to go ahead and use my product property since they're added. And I'm going to write this as the product, log base C of 4x. All right, so now I can use the one-to-one property to make the logs disappear because I have 1 and 1 and the bases match. So I have x squared equals 4x. So I have x squared minus 4x equals 0. This is a quadratic that's factorable. Oh, look, it came back. Factor by stealing. And so then x equals 0 or x equals 4. Right? X equals 0. Each of these factors give me one of my possible answers. So now I've got my 2 possible answers. Maybe. So let's see what happens when I plug these back in. So when I plug these back in, when x equals 0, I get 2 log base C of 0. All right, so I'm already cooked. I know this isn't going to work. Any number to a power is not going to equal 0. So what I'm looking for is I cannot take the log of a negative number or 0. This number right here that I'm taking the log of has to be positive. Okay, so this one is no good. So that's not going to be it. All right, so let's go to the other one. So this one's a positive 4. So this is like 2 log base C of 4. And this is 4 and another 4. This all seems really reasonable. Yeah. So since these end up being, my x values ends up being positive. So I'm running out of room here. Let's write on this other piece of paper. Or I can do it down here. Since I'm taking the log of positive numbers, this one seems to work out just fine. So this one's okay. So my only answer here is x equals 4. So this is another one of those examples when we get false positives. It's shown up in a couple different situations with absolute value, now with logarithms. So it's important that we check our answers. All right, so let's do another one. All right, so here I've got 2 logs. Oh, this is the one-to-one property of 1 log on each side. And they have the same base. So my one-to-one property says I can ignore that. Let's go ahead and set this equal to 0. So I get x squared plus 7x plus 10 equals 0. They are going to be factorable in my experience in the book. So that's nice if you're comfortable with factoring. So they're not going to make you use the quadratic formula for these. So I want things that multiply to 10, positive 10, and add to positive 7. So that would be x plus 5 and x plus 2 equals 0. So when I find my possible solutions here, I get a negative 5 or a negative 2 as my possible solutions. Maybe. So we do have to always check our work. And I'm feeling really doubtful with these negative numbers, but let's just see. So let's see. When I plug in, I'm looking at the right side. When I plug in a negative 5, that is not going to work. It's not going to work. Definitely not going to work. It won't work over here either. This will be 37. Yeah. So let me just show you. When x equals a negative 5, I get log base 3 of, this will be 25 minus 40 plus 12. So this will be 37 minus 40. So I'm taking the log of a negative number. Can't do it. That one's no good. So when I try x equals a negative 2, I think I plug it in here, and I think, yeah, it's not going to be good. So this is going to be 4. I'm going to take the log base 3 of 4 minus 16 plus 12. I'm taking the log of 0. It's not a positive number. I can only log positive numbers. So this one doesn't work either. This one has no solution. I plugged them in, they didn't work. All right, let's do one more and then I'll have you do the U-triads. All right, last one here. So one-to-one property. So I think the temptation might be to like divide here. Don't do it. We have 2 logs over here and we have nothing over there. So can't I just add this to both sides to get my one-to-one? Log base 5, 2x squared plus 8x minus 11 equals log base 5 of 2x plus 9. So now I've got my one-to-one property. So I can ignore my logarithms because the bases are the same and I have 1 log on each side. So there we go. Darn it, this looks like a guess and check. That's okay, I'm feeling good about it. So I'm going to subtract 2x, I'm going to subtract 9. So I have 2x squared minus, plus 6x minus 20 equals 0. So I've got an a is not equal to 1 quadratic. So this is going to be guess and check method. Or some of you got really good at the algorithm. You might want to revisit that. So I know this 2x and x are my first 2 numbers. Now let me think about this for a minute. So my factors for negative 20 are 20 and 1. That doesn't seem reasonable. 10 and 2 and 5 and 4. One of them has to be negative. All right, so I'm going 10 and 2 here for sure. Absolutely. Okay, so if, let's see. if this is a positive 10, then when I multiply this, I get positive 10x. And if this is a minus 2, then when I multiply this, I get negative 4x. So I get the negative 20 for C. And then when I do my insides and outsides, I get a positive 6x. So there's my guess and check right there. Oh, that would have been great. I could have just factored a 2 out of all three of these terms, and then I would have just done it without guess and check. Oh well. So this one has 2x plus 10 equals 0. Subtract 10 and divide by 2. X is a negative 5. This one, I have x minus 2 equals 0. I add 2 to both sides, so x equals 2. These are just possible. These are not for sure answers yet. So we're going to check them. When I plug in a negative 5, I get the log base 5 of 2550 minus 40 minus 11. Oh, that's not going to work. It's the log base 5 of a negative 1. I can't log negative values. All right, so negative 5 doesn't work. So let's check positive 2. X equals 2. The left side of my equation gives me 4, that's 8, plus 16 minus 11. Oh, that's good. All right, so that's 13. That's the left side. On the right side, I put in a 2 here, and I get 4 plus 9 is log base 5 of 13. I get the same thing. Awesome. All right, so that one worked. So that's my answer. X equals 2. All right, try these next two. Let me give you a little hint. This is not a one-to-one property, so let's combine these. And combine these first. This one's pretty much ready to roll. So let's make E one-to-one before you get rid of the logs and solve. And then this one is already one-to-one, so this one's a little more straightforward. All right, so give them a shot. Let's pause it right here, and then these last two answers will be the ending of the notes today. All right, so hopefully you spent 5 hard minutes working on this. Maybe you didn't get all the way, but any progress you make is going to be positive. So remember, we're expecting to make some mistakes. These are kind of tricky. It's a kind of a tricky chapter, but then you're also doing this for the very first time on your own. So don't be afraid of making mistakes, but yeah, please do put in your best effort so that you can build on it. All right, so I noticed this is not my one-to-one. Remember the name, 1-to-1 property. So here is my 2-to-2. So I can't cancel anything because it's not a one-to-one. So I'm going to go ahead and combine. Since this is subtraction, I can use my quotient rule here. So we divide by 2. And that would equal, let's see, first we're going to bring that frog up over the log. So that would be 2 to the third would be 8. So this would be log base 6 of 8 times 10. Right? 2 to the third, frog jumps over the log, adding, so it's the product rule. Okay, so now we have log base 6 of 5x equals log base 6 of 80. So now I can ignore my logarithms. Divide both sides by 5. And so x is possibly maybe 16. Maybe. Not sure yet. So I'm going to go ahead and check. So when I check, I'm just going to do this. Let's see. If I plug in a 16 here, I get the log base 6 of 160. That's a positive number, so that's okay. This one's already set up. This one's fine. This one's already set up and positive. This one's fine, and so is this one. So I guess the only place there was a variable, it worked out just fine. So I'm gonna say it's okay. All right, I like it. So hopefully you got that. Let's go ahead and move on to the next one. So now we've got 2 logs. This is the one-to-one property. These are already one-to-one. 1 log equals 1 log with the same base, so we can get rid of the logs. Let's just go ahead and now subtract 6x and subtract 1. So I have plus x minus 6 equals 0. That's what happens when I move everything to the left side and have the one-to-one property cancel my x's. So this is factorable. As I told you, most of these ones, especially in the homework, are factorable or linear. If they're quadratics, they're usually factorable. So I want things that multiply to negative 6 and add to positive 1. So those things are a positive 3 and a negative 2. And then those factors give me these possible solutions. Maybe. Not sure. We're going to check. I'm especially wary. It's no guarantees. I'm especially wary of the negatives. So let's check. When x is a -3, this would be 9 minus 21 minus 5 equals log base 10 of -18 plus 1. I can't take logs of negative values. These are both negative values. It doesn't matter that they equal each other. I'm still taking the log of a negative, and that is not allowed. So that one's no good. So now I'm going to go ahead and check. X equals a +2. So on the left side, that would be 4 plus 14 is 18 minus 5. 4 plus 14 minus 5. So that's 13. Log base 10 of a +13. So that's the left side. On the right side, I plug in a 2 there. I get 6 times 2 is 12 plus 1. So I get log base 10 of 13. Both positive, both the same. I like it. So that's my answer. X equals 2. So hopefully you got those. Those should definitely help you with the homework. So I'll leave this here, and you can go ahead and access this on my YouTube channel if you missed some pieces. Best of luck, and yeah, I'll see you in a couple of days.